In section 8.1, I'm going to be solving systems of linear equations in two variables. Now, first of all, we're going to discuss on what's a system. A system refers to two or more linear equations. When I say a system of linear equations, means two or more linear equations. So there are three different cases of linear equations that I want to discuss to you about first. Okay, so this tells you basically just the definitions of what a linear equation is. It's a straight line. Okay. And then a couple of concepts that you need to keep in mind. A linear system has at least one. A linear system that has at least one solution is called consistent. A system that has no solution is called inconsistent. Now, what I want to talk to you about is what are the three different cases for what the solutions of two linear equations look like. So if I give you two lines and I ask you to find the solution for the system, that basically means find the solution that both lines have in common, and that would happen when wherever the two lines basically meet. So in the first scenario that you have here is that the two lines intersect at one point. So that means that the solutions could have exactly one solution, and that is represented as an ordered pair. Now, on the second case that you see right here in the picture is that these two lines do not intersect. When two lines do not intersect, that means that the lines have no solution because they're parallel. They don't have any points in common. Okay? The solutions of one line are different from the solutions of the other line. So there's no common solutions. So the solution for the system, remember, it has to be a solution to both of them. So there's no solutions from this one that will also be a solution for this one. So that's why we say no solution. Now, when the system has no solution, we say that the system is inconsistent. And to say no solution, there's a symbol that represents no solution, and it is this. This is called the empty set. Empty set means that the solution set is empty, which is the same thing as no solutions. Okay. Now, the last case you see is basically, it looks like it is exactly only one line, but in reality, there's two lines. But one line is right on top of the other line. Okay. When that's the case, then that means that every point between them is a solution because they intersect everywhere. So in that particular case, we say that the solution of these two lines is infinitely many solutions because there's coincidental lines. The two lines are exactly identical. So they have many solutions in common. Now, when the solution is infinitely many solutions, we still write the solution as an ordered pair, but we write it in the form of an equation. Which generally, this is the most usual way of writing the solution. Okay? We want to write the solution in terms of x or in terms of y, and the most common way is writing the solution in terms of x, meaning I want to write an equation with the letter x that will generate all the solutions for the system for any value of x that I substitute. So if x is equal to 1, I get such solution. If x is equal to 2, I get such solution. If x is equal to 3, I get such solution, and so on and so on and so on. So I need an equation that generates each one of the solutions. Okay. Now, let's go ahead and start talking about basically how do we check a solution. That will be the first case here. Now, the first question states on we want to determine whether the given ordered pair is a solution of the system or not. So, to find out if a given ordered pair is a solution, all we have to do is we're going to substitute that ordered pair into both equations to determine if it is true on both. Okay, so this is my x and my y, right? So what we're going to do is go to the first equation, y equals to 6x minus 10, and I'm going to substitute the y with the -4 right here, and the x with the 1, and see if this is true. So 6 times 1 is 6, minus 10, that's going to give me a -4, and -4 is equal to -4, so that's a true statement, right? So that means that 1 comma negative 4 is a solution of the first equation. Now, let's check the second one. 2x plus 5y equals negative 18. So x is equal to 1 and y is equal to negative 4. So then right here, 2 times 1 is going to be 2. 5 times negative 4 is minus 20. And 2 minus 20, it's going to be negative 18. Negative 18 equals to negative 18. That is also a true statement. Now, then that means that 1 comma negative 4 is also a solution to 2x plus 5y equals negative 18. Now, since the point 1 comma negative 4 is a solution to the first equation and to the second equation, then we can conclude, therefore, 1 comma negative 4 is a solution of the system. It is a solution of the system, because the system means that it is a solution to all the equations, in this case to both of them. Okay? This is basically how we check a solution. Now, I'm going to show you with two different methods, substitution and addition. Those are the ones we're going to use to actually find the solutions of the systems of linear equations. Let's start with substitution. Now, on the method of substitution, this is how it works. The first step of the substitution method is that you need to solve one of the two equations for one variable. Okay? Solve either one of the two equations, you're going to solve it for one variable. Then what you're going to do after is whatever that equation equals to, you're going to substitute that expression from that equation that you solved, you're going to substitute it into the other equation. Okay? And once you substitute it, your new equation is going to have only one variable. So what you're going to do with one variable, you're going to solve for it. That's going to give you your first variable, which is going to be either x or y. Then after you find that variable, to find the second one, the other variable, you're going to substitute the value of that variable you found into one of the original equations to find the value of the other variable. And this is optional. You can check your solution by substituting the solution into both equations to see if it is true. But again, this is optional for you to do if you want to check your solution in case there is a need. Okay. So let's go through the process of substitution in the first question here. Question number 1, it says, solve the system by the substitution method. So, for the substitution method, the first step in the process is that you need to solve one of the two equations for one of the variables. So, in this particular problem, we don't need to do that because, as we can see, the second equation, it's already solved for the variable x. For the variable y. So, we already have the second equation solved. So, all we know is that y equals 4x minus 13. So we're going to go to the second step in the process, which tells you, since y is equal to 4x minus 13, I'm going to substitute this equation into the y of the first equation, because that's what the y is equal to. So then my new equation is going to be x plus 2y equals to 10. But the y is going to be 4x minus 13. That's the value of y that we obtained from the second equation. So then step number 3 tells you that you need to solve the new equation that you get for the letter that is left. So you see that you have only x. So you're going to solve it for x. So if I want to solve this equation for x, the first thing is that I need to distribute this parentheses. So it's going to give me x plus 8x minus 26 equals to 10. Then we can combine like terms. That's going to be a 9x minus 26 equals to 10. Then we can add the 26 to both sides to leave the x by itself. So that gives me 9x equals to 36. And then we can divide both sides by 4. So x is equal to 9. Divide both sides by 9. And that gives me x is equal to 4 as the solution. So this is the value of x for the solution. However, the solution, as you remember, it must be an ordered pair. So for that solution, we already know that x is equal to 4. Now the question is, how do we find the y? That is going to be my last step in the process in step 4, which is we need to replace this value of x back into either one of the two original equations. So I'm going to go ahead and use the second equation right here. So we know y equals to 4, but we already know that x is equal to 4. So it's 4 times 4 minus 13, 4x minus 13. So y is going to be 16 minus 13, which is y equals to 3. So that means that when x is 4, y is 3, so the point 4, 3 is the solution for this system of equations. And just like I mentioned to you, you can always go back and check your solution, but this is optional. If you want to check the solution, you can go ahead and substitute that solution back into both the first equation and the second equation and see if that gives you a true statement. That's basically what I need to do. So I will put x, which is 4, plus 2 times y, which is 3, equals to 10. So that gives me 4 plus 6, and 4 plus 6 gives me 10, so 10 equals to 10. That is a true statement. If I check it from the second equation, y is 3. 3 equals to 4 times x, which is 4, minus 13. That is going to be 3 equals to 16 minus 13, and that gives me 3. So 3 equals to 3 is a true statement. So that's how we can check if the solution is correct, substituting it into both equations to see if it is a true statement. Alright, on the next problem, we're going to solve the given system by substitution. We got 2x plus 3y equals 0, and x minus 2y equals 0. So, on this one, first thing we need to do is we need to solve one of the two equations for one of the variables. Now, the easiest possible case, and I would recommend you do this, would be to solve for a variable, if possible. Of course, it is not always possible, but solve for a variable that has a coefficient of 1. That way we can avoid getting fractions in whenever we're solving. So right here you see that the only one that has a coefficient of 1 is the x. So if I solve for x, this is the easiest one that I can possibly do, because I'm going to get no fractions in this one. So to solve for x on this equation, what I have to do is move the 2y over as plus 2y on both sides. So it gives me x is equal to 0 plus 2y, which is 2y. So we already know that x is equal to 2y. So now step number 2, since x is equal to 2y, we're going to replace this 2y into the x of the first equation. So then my new equation is going to be 2x, but the x is going to be replaced with the value of x from the second equation, which is 2y. Then you see plus 3y equals 0. And my new equation here ended up with only y, so all I got to do is solve for y. So we're going to distribute right here. So it's going to give me a 4y plus 3y equals to 0. Then we can combine like terms. That's 7y equals to 0, and then we divide by 7 on both sides. 0 divided by 7 is still 0. So that is the solution for the y. So what do I need to do next to find the value of x? We're going to substitute that value of y into one of the two original equations. So I'm going to use the second one. X minus 2y equals to 0. But we already know that y is equal to 0, so I'm going to replace the y with the 0 here. 2 times 0 is going to be 0. So x is equal to 0 as well in that one. So the solution for this system of equations, there is also one solution, and the solution is the point 0, comma 0. These two lines intersect at the point 0, 0. And then if you want, remember you have the option that you can substitute these two values back in the original equations to verify if the solution is true. Okay, that is just an additional thing that you can do, which is checking your solution. The next one. Now we're going to solve this system by the substitution method. Now, on this particular problem, what you can see is that, well, both equations are already solved for y, both of them. So what does that mean? Since y is equal to 2 7 x plus 4 7, I can just go ahead and substitute this into the y of the other equation, or vice versa. Since y is equal to 1/5 x plus 1, I can substitute this 1/5 x plus 1 into the y of the top equation. Either way, we're going to get the exact same thing. So then my new equation is going to end like this. Y, which is going to be substituted with 2 7 x plus 4 7 equals 2 1/5 x plus 1. And then we just have to solve this equation for x. Now, if you look at this one, this equation contains fractions. So in order for me to solve this with fractions, the easiest thing to do is for us to multiply the least common denominator on both sides of the equation. So the least common denominator of 7 and 35. 7 and 35, they can both be multiplied to 35. So what I'm going to do is that I'm going to multiply the 35 on both sides of the equation. So that way we can get rid of the fractions. So right here, 35 times 2 is 70 over 7x, but 70 over 7, it's going to give me a 10x. Now, 35 times 4 is 140. 140 divided by 7, it's going to be a 20. So 10x plus 20 equals, we have the equal sign. Then we're going to multiply right here. 35 times 1, it's a 35 divided by 5x. That's going to give me a 7x. And the last one is 35 times 1, which is going to be a 35. That one just stays as a 35. So that gets rid of the fractions. Now if I want to solve for x, all I need to do is put the x's together. So I'm going to subtract 7x from both sides. That gives me 3x plus 20 equals to 35. Then I'm going to move the 20 as minus 20 to the other side. That is going to give me 3x equals to 15. And then divided by 3 on both sides, that gives me x is equal to 5. So that is the value of x for this system. Now remember that the solution for the system, it must be an ordered pair. So we already know that x is equal to 5. Now in order for me to find the y, I need to go to one of the two original equations, the first or the second, and replace the 5 into the x. So I'm going to use this time the second equation. Y equals to 1/5 x plus 1. But we already know that x is equal to 5. So I'm going to replace the x with the 5. So then right here, what do we get? 1/5 times 5, it's going to be 5 times 1 is 5, divided by 5 is 1. Plus 1 is going to give me y is equal to 2. So that means that the solution is going to be the point 5, 2. And this is the solution for the system. Remember that you can always check the solution by replacing that 5, 2 back into both original equations and see if that gives you a true statement on both. Next one. Now we're going to be solving systems of linear equations using the other method. The other method is going to be called by addition. This is the second method you need to be familiar with, the addition method. Now, for the addition method, the first thing you have to do is you need to make sure that both equations are in the form ax plus by equals to c. This is called the standard form. Okay? Both equations must be written in standard form. Second step in the process. Now, it tells you that if necessary, you're going to multiply either equations or both equations by numbers so that when you add the x's or when you add the y's, it gives you a 0. Basically, this is telling you that I need to multiply, either the one equation or both, so that when I add them, they give me a 0. Meaning, when does that happen? When both numbers are the same number but opposite signs. So the goal for this is that you need to make either the x's or the y's to become the same number with opposite signs by multiplying one equation or both equations by whatever is needed so that you make them become the same number. Now, after you make them become the same number, either the x's or the y's with opposite signs, then you're going to add both equations together. Now, when you add them, either the x's or the y's, whichever ones you make the same number with opposite signs, is going to cancel. Cancel means that it's going to become a 0. That's what we wanted. Okay? And that's going to leave you with only one variable. That's what you're going to have left. So what you're going to do next, you're going to solve that equation for that one variable that you have left. And to find the value of the second variable, you're going to substitute the value that you found in step 4 into any of the two original equations to find the value of the second variable. And last but not least, this is something optional. Check your solution by substituting the solution into both original equations if needed. This is just going to be optional. If you don't have a need to substitute it, if you don't need to check it because you're sure of your solutions, you don't need to check the solution. Now, let's go ahead and get started with the process of addition, starting with this problem. Solve the system by the addition method. Now, in this problem, we need to verify first of all that both equations are written in the form ax plus by equals to c, which, as you can see, both of them are already in that format. So I'm going to rewrite it because I don't want to mess up the originals. So both of them are already written in the desired format. So what we need to do next is we need to multiply one equation or both equations by whatever numbers needed so that the x's or the y's give me the same number but opposite signs. What do you notice here? The y's have already the same number and opposite signs. So I don't need to multiply anything in this system. So all I need to do is go to step 3. Step 3 tells you add both equations together. Okay, so 3 plus 4x is going to be 7x, and 15y plus negative 15y is 0, cancels, equals 9 plus 12, it's going to be a 21. So you end up with 7x equals to 21. Step number 4 in the process is that you need to solve for that variable that you have left, which is x. So to leave the x by itself, we're going to divide by 7 on both sides. So that gives me x is equal to 3. That gives me the first value, so which is my x equals 3. Now, if I want to find the second value, which is the y, all I need to do is replace that x with the 3 into one of the two original equations, either one of these two. So I'm going to go ahead and use the first one. 3x plus 15y equals to 9. We already know that x is equal to 3, so I'm going to replace the x with the 3 in this system. So that gives me 3 times 3, which is 9, plus 15y equals 9. Subtract the 9 from both sides. That gives me 15y equals to 0. And then I divide both sides by 15. And so 0 divided by 15 is going to give me a 0 still. So my solution for this system of equations is going to be the point 3, 0. And don't forget that you can always check your solution. That will be the last step if you want to. by replacing those two values back in both equations to see if it is true. Now, next system. Now we're going to solve this system by the addition method. X plus 3y equals 5, 3x plus 2y equals negative 6. So in this particular case, I want you to take a look at something. Well, first of all, ax plus by equals to c. We need to make sure that they're both written in the form ax plus by equals c, which in this case both of them are. So we're going to go directly to the second step in the process. Second step in the process tells me that I need to multiply one equation or both so that the x's or the y's by a number so that the x's or the y cancels out. So right here, for example, on the x's, let's say I want to cancel out the x's. What do I need to multiply so that the 3 and the 1 have the same number but opposite signs? Well, this is the smallest one. So what I'm trying to multiply is multiply the smallest one first. So that 1, to make it the opposite of 3, the opposite of 3 is negative 3. All I have to do to make it a negative 3 is multiply by negative 3. And that way it's going to become the opposite of the bottom. So that's basically what the second step is. Making the same number, opposite signs, by multiplying it by a number, either one equation or both. So negative 3 times 1x is negative 3x. Negative 3 times 3y is minus 9y equals negative 3 times 5 is negative 15. And what we have to do is we need to add it to this other equation. 3x plus 2y equals negative 6. So when we add these two equations, that's a step 3. That gives me a 0x, which means they cancel. Negative 9y plus 2y is negative 7y equals negative 15 plus negative 6 is negative 21. And my new equation ended up with only one letter, with the y. So how do I leave the y by itself? By dividing both sides by negative 7. So that gives me y is equal to positive 3. So we already know from the solution that the y is equal to 3. All I need to find out is what x is equal to. So we're going to go back to one of the two original equations and we're going to replace the y with the 3. So I'm going to go to the first one. X plus 3y equals 5. So we already know that y is equal to 3 right here. So I replace the y with the 3. So that's x plus 3 times 3, which is 9, equals 5. To leave the x by itself, we're going to subtract the 9 from both sides. So x is equal to negative 5. So the solution for this system of equations is going to be the point negative 5, comma 3. So the two lines intersect at negative 5, 3. If you want to check your solution, remember that you can substitute this solution back into both original equations and see if it is a true statement, if it gives you a true statement on both. If it doesn't, you have to go back and recheck your work to see what is it that was done wrong. Okay. Alright, so the next problem. We're going to solve the following system by the addition method. So let me check something first. Yeah, so let's solve this one. Solve the system by the addition method. So, step 1 has to be in the form ax plus by equals to c, which in this case both of them are. So, in this particular problem, what you have to do is, you see that if I want to cancel out the x's, 4 times nothing is going to give me 5. If I want to cancel out the y's, 2 times nothing is going to give me 5. So in this particular case, we need to multiply both equations because by multiplying one, we don't get the other value. So let's say I'm going to cancel out the y's because in this one, I already have a minus and a plus. So the only thing is that I need to make them the same. If you cannot just multiply one equation to make it the same as the other one, then what you're going to do, the value from the top equation, you're going to multiply it in the bottom equation, and the value from the bottom equation, you're going to multiply it into the top equation. So that way, in this case, both of them will become 10s. I cannot make the 2 a 5, but I can make 5 and 2, both of them become 10s. That would be the same case with the 4 and the 5. If I wanted to cancel out the 4 and the 5x, the 4 I need to multiply it on the bottom equation, the 5 on the top equation, and then, but one of them in that case needs to be a negative. That would be the only difference. Okay? So, if I multiply the first equation by 5, we get 20x minus 10y equals 50. Second equation, 10x plus 10y equals 40. Then we need to add these two equations. That gives me a 30x, the y's cancel, equals to 90. And if I want to leave the x by itself, I divide both sides by 30, and that gives me my solution for x, so x is equal to 3. So, to find the y value for this solution, I need to replace the x with the 3 in one of the two original equations. So I'm going to substitute it into the second one. So it's 5x plus 5y equals to 20. But we already know that x is equal to 3, so we're going to replace the x with the 3 right here. So 5 times 3 is going to be a 15 plus 5y equals to 20. I'm going to subtract 15 from both sides. That's going to give me a 5y equals to 5, and then we divide by 5 on both sides to get rid of the 5, and we get y is equal to 1. So that means that these two lines intersect at the point 3, 1. So 3, 1 is the solution for this system of linear equations. Alright, so the next one. The next thing that we're going to do is we're going to solve systems by the method of your choice. Or before we get there, so we're going to do one more with the addition method, this one. Solve the system by addition. In this problem I want to do it because if you look, first thing that you need to do is write it in the form ax plus by equals to c. And in this case, none of them are in that form. So in order for me to write it in that form, first thing I have to do is I need to move the y over to the left side right here as a minus 5y. If I want to put this in the form ax plus by equals c, I need to move that minus 4y to the left side as a plus 4y. And now both of them are in the form ax plus by equals to c. Now it is. Now, second step in the process is that now we need to multiply one equation or both so that the x's or the y's cancel. In this case, if we look at the x's, all we gotta do to make both of them the same is I can make the 3 become a negative 9, which is the opposite of 9, by multiplying this equation by negative 3. So if I do that right here, if I multiply by a negative 3, then you're going to get negative 9x, then negative 3 times negative 5y is positive 15y, equals negative 3 times 9 is negative 27. And what we have to do then is we need to add it to this equation. So it's 9x plus 4y equals negative 4. So when I add these, you're going to get that this cancels, then you get 19y equals negative 27 plus negative 4 is negative 31. And then to leave the y by itself, I divide both sides by 19. So we get y equals to negative 31/19. It's going to stay as a fraction. Negative 31/19. So, if I want to find the value of x, what we need to do now is that we need to substitute this answer back into one of the two original equations. So I'm going to go and pick the first one. So the first one says 3x equals to 5y plus 9. We already know that y, it is negative 31/19. So if I multiply negative 31 times 5, it's going to be negative 155. So So you get 3x equals to negative 155.19. We're going to add the 9 to it. So I'm just going to do it here in the calculator, or you can just multiply 9 times 19 to make it into the same denominator. So you can put the 9 into 19, but right now I'm just going to put it in the calculator. So negative 155.19 plus 9, that gives me this. And then to make it into a fraction, you press math and enter 2 times, and that gives me 16/19. That gives me 16/19. Then what I need to do is divide the 3 on both sides. Or, since I'm dividing by a fraction, it would be best if I do this. Divide by 3 is the same thing as multiply by 1/3. So that way we know, since there's fractions, it's more understandable this way. So this one is going to give me x is equal to, so if I multiply the 16/19 times 3 times 1/3, that gives me this fraction, which as a fraction is going to be math enter enter. It gives me 16/57. So this is my solution. I'm going to write the solution down here. So the solution for this system of equations, or the point of intersection of these two lines, is going to be the point x, which is 1657, comma y, which is negative 31/19. And that's the point of intersection of these two equations. Once again, if you want to check your solution, you can replace these two values back in both equations to see if it gives you a true statement on both. To finalize this section, we're going to cover 2 special cases. Okay? We're going to solve the following system by the method of your choice, either addition or substitution. And in this case, I'm going to solve this one by addition myself. Okay. But remember that if I want to solve it by addition, both equations must be in the form ax plus by equals to c. In other words, I need to move the y over to the left side on the first equation, and that is going to give me 3x minus y equals negative 3. I just changed the y to a negative y. Then the second equation is already set up. 3x minus y equals to 3. So now both equations are in the form ax plus by equals to c. Step number 2. Let's say, for example, if I wanted to cancel out the x's. Both of them already have the same number. There's only one thing that we need. One of them must be a negative, which means that either you multiply the top equation by a negative 1 or the bottom equation by a negative 1. So, for example, what if I multiply the bottom one? That gives me a negative 3x. Negative 1 times negative y is positive y equals negative 1 times 3. It's a negative 3. And then we're supposed to add it to the second equation, which is 3x minus y equals negative 3. So if I add them, what happens? Both the x and the y cancel, and that leaves me with 0 on the left side, equals negative 3 plus negative 3, which is negative 6. So this is a special case. Anytime both the x and the y, both variables, or all your variables cancel out from the system, that means that is an indication that the system has either a no solution. No solution means that there's no points of intersection between the two equations, or infinitely many solutions, meaning that the lines coincide, meaning that they intersect at every point. Okay? All we have to do to determine whether it is no solution or infinitely many solutions is determine if this statement is true or false. 0 equals to negative 6, that is not true. So we're going to say that this is a false statement because 0 is not equal to negative 6. So if it gives you a false statement, that automatically means that this system has no solution, or the system is inconsistent. Remember, the definition of inconsistent means that it has no solution. And that's all we have to do for this. That's no solution, so there's nothing we can do. There's no points of intersection. and the last case of the system is going to be this one. We're going to solve the following system by the method of your choice. So for the method of your choice, in this case, I would choose to use substitution for one specific reason. And my reason for using substitution is that, again, that doesn't mean that you cannot use addition, but I'm just saying that substitution for me would be my best choice because, as you can see, the first equation, it is already solved for x. And that is the method of substitution, that is the startup. So since it is already solved for x, all I have to do, this is x is equal to 2y plus 8, so I'm going to replace that value into the x of the bottom equation. So that's going to give me 3 times x minus 6y equals to 24, but the x is going to be replaced with 2y plus 8. And then we're going to solve this equation for y. So we're going to distribute. So that gives me 6y plus 24 minus 6y equals 24. Then we can combine like terms. 6y minus 6y, unfortunately, it cancels out. So this is another situation that you can see, another special case, in which both the x and the y disappeared from the system. That automatically means that the system has either no solution or infinitely many solutions. But in this case, if you look at this statement, 24 equals to 24, in this case we got a true statement. If that happens, that means that the system has infinitely many solutions. And just like I explained when I was going over the definition, is that when you have infinitely many solutions, you have to write the solution in terms of x or in terms of y. Generally, the best way to write it is in terms of x. So we're gonna create a set of equations that we're gonna generate a set of equations that will generate each one of the solutions for any given value of x that you replace into the equations. So I'm going to put it in terms of x. Okay? So in terms of x means that x is going to be the variable in my equation. Now, the first variable, it is already x, so we don't need an equation for that, so I can just put x for that. All we need is an equation for y in terms of x. How do we find that? Well, very simple. You're going to get one of the two equations, whichever one. Now that since we know that they have infinitely many solutions, just trust the following. That means automatically that both equations are exactly the same equation. Okay? So you can pick whichever. So I'm going to get the second one. And what I am going to do with the second equation to get that y, I need to solve it for y. That's what we need to do. Solve it for y to get my equation for y. So I'm going to move the 3x over to the other side. So that gives me negative 6y equals negative 3x plus 24. And then you're going to divide both sides by negative 6 right here. So negative 3 cannot be divided by negative 6, but I can reduce it to 1/2 x. And 24 divided by negative 6 is minus 4. So this is the equation that will generate all the values of y. 1/2 x minus 4. So let me tell you what does it mean by this solution. So if I substitute, for example, you don't need to write this down anymore. This is the solution right here. If I substitute x with the 1, x with the 1, what am I going to get? 1 comma 1 times 1/2, which is 0.5 minus 4 is negative 3.5. So this is one solution. If you substitute this point into both equations, it's going to be true. So what if I substitute x with the 2? 2 comma 1/2 times 2 is 1 minus 4 is negative 3. I bet you that if you also substitute this point 2 comma negative 3 into both, it's also going to be true. Now what if x is 3? What if x is 4? What if x is 5? And so on and so on and so on. It doesn't matter what point I generate by substituting any x into this equation. Every point that I generate from it it's going to be a solution to the first and the second equation for sure. Okay, and this problem concludes section 8.1, which is systems of linear equations in two variables.